Maybe
And
we'll.
hello. Yeah, I'm Dmitry, technical co-founder and CEO/CTO at SQD Dev. And today we're gonna discuss the architecture and how the SQD network actually works.
Yeah. Is it a question you often get?
No, to be honest.
So you're not like answering this all the time.
Well, actually, this is the question that I get from the developers and those who are interested in our tech. And that is usually quite interesting to answer. Also, we have a lot of information in our docs and in our blog post. But I guess like for the wider audience, normally people just opt in for a very general discussion. And today I just want to shed a little bit more technical details. I think they're quite interesting and unique on their own.
Yeah, definitely. So maybe we just kick it off and I give you the stage and you can take it away from there. And then whenever something maybe is not comprehensible to me, I might stop you and say, can you explain for like I'm five? And I think this way we can address all of the people.
Yeah, absolutely. So I definitely try to simplify things as much as possible. I do not promise and do not guarantee that it's going to be as accessible as for a 5-year-old, but I will try to make it as simple as possible. All
A
right.
5-year-old by a PhD candidate, maybe.
Yeah, a 5-year-old PhD candidate should be fine.
Yeah.
All right. So here we go. Let me share my screen and slideshow. All right. Can you see it?
Yes.
All right, so off we go. SQD Network, the Web3 data layer. So first, like before we go into any details, let's just discuss why SQD Network, what we are actually trying to build, and why, and what problems we're solving. And then I will go into brief overview of how the network works under the hood. I'm not gonna touch a lot on the economics. This is probably like a separate topic, and maybe we will have a separate stream on the economics of SQD in the future. But I will describe how one can actually use the network, and at that point, you actually need to buy and expand SQD tokens, and this is like a separate flow. It's different from running a node in the network. And finally, we will touch upon the future plans, because right now, even though the SQD network is fully live and on mainnet, we are just at the beginning of our very long journey, and the final destination is omnipresent data ocean that can serve all the Web3 data in the most general format and in the most secure way, so that it is accessible for all kind of applications. All right, so why SQD? Actually, the answer is in this picture. This picture shows how the state of all the major networks grow over the time. And you'll see that for quite a long time, the growth of the data wasn't really a concern until we got to the point where we have something similar to what we call adoption. We got Ethereum, which started to grow. Then we got Binance Smart Chain with a lot more users, and the state started to grow exponentially. And now we have Base, now we have Solana, now we have this next generation chains, which promise to have hundreds of thousands of transactions per second. And it is obvious that the amount of information and amount of data produced by this chain is just so large that you cannot really serve it with a single blockchain node. So, in a nutshell, blockchains were designed to execute and achieve consensus, but not serve the data. And right now, the key innovation is actually happening on how to make a lot of throughput, but nothing is actually done on how to serve this data. And without accessing the data, it is impossible to build any kind of application that we all want to. So the solution really is to separate these two concerns, and so let the blockchain nodes focus on consensus and the execution, so you actually can send as many transactions as you want. But when it comes to the data, let's just build a separate layer, a separate solution that would allow you to query this data efficiently, and also so that it can handle as much data as we need. So then the nodes are not constrained by this floating state anymore, and it becomes just sort of an execution machine. This is exactly the idea behind the SQD network, which I call a data ocean, meaning that it gobbles up all the data from all the different blockchains in a single distributed database. And basically, we have then blockchains, which execute smart contracts, accept transactions, reach consensus over the global state, and we have a process that moves all the historical data, transactions, and whatever you would expect to query from a blockchain node into this separate data ocean, specifically designed to handle arbitrary amounts of data. And this network is not meant to be a blockchain. It doesn't really have to reach consensus or execute any instructions, but instead is optimized to provide permissionless access to all the data that is written into it and efficient search and queries against this data. So what is SQD network? Probably I should start with saying what SQD network is not. So SQD network is not a storage solution like Filecoin or Arweave. SQD network is not a data availability platform. So it's not something similar like Celestia or EigenLayer, which is really more of a consensus machines or like facilitate consensus. But what SQD network is a specialized, decentralized, distributed database specifically designed to handle petabytes of on-chain data. And it's on the economic side, a DePIN network, which is powered by the SQD token, meaning that it's thousands of machines running off-chain with the settlement layer on smart contracts in Arbitrum 1. So once again, SQD network is not a blockchain. It's essentially a DePIN-powered distributed database, which is permissionless and which is powered by SQD token on Arbitrum 1. The way that SQD network works, provides permissionless access to the entirety of on-chain data, and we cover most EVMs in Solana, including Base, Polygon, Avalanche, and like all the major ones. It's a powerful query engine for granular filtering and extracting only the data you are actually interested in. This is specifically important for application builders who run indexers. And finally, it is designed to provide cryptoeconomic guarantees on the data validity, so that essentially, there is no difference whether you run a blockchain node yourself and query the data from there, or you just take the data from the SQD network without providing any kind of infrastructure. So essentially, you get the same crypto economic guarantees as if you were running a node. What problems does SQD network solve? So first of all, it's very fast data access. And it is already hundreds times faster compared to what you get from querying RPC nodes for many reasons. First of all, the RPC nodes internally have a very specific database which is not really designed for queries, for searching the data. And second, that RPC nodes from the very beginning were designed for achieving consensus, as I said before. And so as an API server, or like as a box that serves the data, is really a very bad solution. So that seems like a technical problem to solve, but it has very severe consequences. In particular, solving the data access means a lot better user interface and a lot better developer experience. And this, in turn, means a lot more usable applications and a lot faster adoption of the blockchains. Another problem that we're solving is data fragmentation, which comes from the fragmentation across the networks. We are entering a world where we have hundreds of chains, and probably we're going to see thousands of chains, and we are yet to see any way to combine this data and combine these chains to unify user experience. And one of the key problems is to put the user activity into a single place. And SQD Network actually solves this very elegantly, simply because we already have this data in a single place. And as a developer, it is trivial to fetch this data and aggregate it. And so your application is network agnostic and omni-chain by design. And finally, with the SQD network, we solve the data centralization and vendor lock-in. This is a very important problem because you basically don't care about decentralization until you have to. For example, if you're censored, if you're, for example, under sanctions, or you somehow have restricted access to the network, and you want to access one of the major DeFi applications, for example, Uniswap, and you can connect to the website, you can even maybe interact with a smart contract, but finally it turns out that you have to use Infura or Alchemy or like one of any other centralized infra providers. And it turns out that they are mandated to block your API, to block your IP, and you just cannot use the application, even though it is assumed to be on-chain and decentralized. So that means that having just a smart contract is not enough for censorship-resistant permissionless access, but one has to decentralize the whole stack. So accessing the data in a permissionless permissionless way is important, just to make sure that the whole premise of Web3 stands. Because right now, we kind of care about censorship resistant on the smart contract layer, but we do not care about everything else, like once we build the actual application. And SQD Network actually solves that. Okay, let's go into some technical weeds for now. So how does SQD Network work? The data first is extracted from different blockchains, and this is not even a part of the SQD network, but very important process that is put into the data provider box here. So basically, what happens is that there are multiple processes that pull this data consistently from different blockchains through RPC interfaces. That are slow, but this process only is only done once. And once you get this data, the special ingester process packs them into large Parquet files, which are it's a special format that optimizes for querying and for putting this data in such a way that you can easily extract only the necessary parts whenever you query it. So this is what is called columnar format. And it's basically like a database in its own, but packed into a single flat file. And as this picture illustrates, every now and then, each of these ingesters produces a new Parquet file for the new blocks that arrive from the network. And all of these files are put into a huge bucket, which is called a permanent storage. Permanent storage means that the data just sits there, and these files are available for download. Currently, we use a centralized provider for that, and we will later support things like IPFS and RWEF. But for now, it's just important to know that these files are durable and easily accessible by unlimited number of consumers. And then we have the SQD network itself. So this is a cluster of many nodes, and each node picks a small subset of the files stored in the permanent storage and downloads it into a local cache. So as you see on this picture, this whole bucket is getting randomly distributed across many workers in the SQD network. And as you can see, there is also some redundancy here. So for example, the yellow box is present on multiple workers. So if any of those dies, it is still available through multiple machines. So the network is designed in such a way that the workers take some random piece of the data, but the network itself covers the full entirety of the data. And more so, each piece is replicated across multiple machines, so you have the maximal possible redundancy. There is an economic component to the network, so that the workers are economically incentivized for keeping this data, and they also serve this data for clients that access these workers directly. So basically, each worker is like a mini API server, which is responsible for serving the data stored in local cache. So essentially, instead of having a single API endpoint, one can think of SQD network as like thousands of mini API servers, each serving a small range of blocks for each blockchain. This is a live screenshot from the SQD network mainnet dashboard. You see that we already have more than 1,100 workers, and they already serve more than 12 terabytes of data each day, even though this is actually more like a standby mode, as we haven't really launched our key product I'm going to talk about next. And you see that also the data here is around 150 terabyte, but the total capacity is more like 1.1 petabyte. That means that each piece is replicated from 7 to 10 times, and there is like a very high redundancy there. Now we come to the point of how exactly the data is queried from the SQD network. So far we have a very simplified diagram of how the data gets in, but then let's see how the data gets out. Well, as I said, the key promise is to provide a fully permissionless open access to the data. And for that, the idea is that you can run a special client, which we call portal, that directly connects to the workers storing the data of interest, and then you can query this data in a peer-to-peer fashion. So, for example, on this picture, you're interested in this red circles, which say is a very it's, for example, Uniswap transaction data on Ethereum. And you see that there are only two workers that store this data. So what the portal does under the hood is that it locates the right workers, connects them directly, and asks them, okay, like give me only the red circles. And then the portal aggregates it internally, and you get an uninterrupted stream of this data that is served directly from the network. You can think of this portal as a sort of a BitTorrent client that you run on your laptop, but so that it actually knows to which worker one should connect in order to query each specific piece of the data. And also, the bandwidth is controlled by locked SQD tokens, so that you cannot really abuse the system, but rather, if you want to have a lot of data, you have to acquire more SQD, and this is the key driving factor for the demand. So we expect that as we launch the portal and we see more and more need for the data, there will be more and more demand for SQD tokens. Now let's go and see how one can actually registers and runs a self-hosted portal. And this is actually a spoiler alert, because this is not something that is fully released, and it's a preview against the test. So some labels may change, and but the flow actually going to be the same. So you first run a small binary to generate your portal identifier, which is called peer ID, so that you can register it into the network. Then you go to the special web page, which is an interface for the smart contracts responsible for keeping track of which peer IDs and portals are in the network. You register it, and then you lock SQD in order to get some throughput allowance for the network. These are called compute units, and there is a rate that tells you how many requests you can make for each SQD locked. Normally, that will be around 100K SQD for servicing a throughput required for 3 to 5 indexers run in parallel against any kind of data profile. So once you register your peer ID and lock your SQD for throughput, everything is fully set up, and basically you have a fully functioning API that can stream data on demand. Together with the self-hosted options, we are going to provide a lot of semi-centralized and centralized options, so that if you don't want to mess up with the tokens, or just want to try things, you can just go away and run your queries against this API in pretty much the same way as you do for any kind of RPC provider. So there will be hosted portals by our partners. There will be a public, no strings attached, easy to use portal hosted by SQD Labs, and also all the indexers deployed to SQD Cloud will enjoy a dedicated portal and access to the SQD network. So basically, everything will be seamlessly migrated from the current centralized setup to this fully decentralized SQD network, and of course, at no charge. And basically, all the clients will get just simply more reliable and faster access to the data that they already have. Now, let's peek into the future. And as I said, this is just the beginning. And for now, we've been focusing on providing very fast access to the on-chain data and providing this historical data to indexers. But a lot more opportunities open up once you adopt this ZK crypto magic, so that you can verify the answers directly in smart contracts. That would turn SQD network into what is now called a data co-processor, meaning that it will be possible for a smart contract to query arbitrary data across any chain, and no matter how deep into the history. So, for example, you would be able to make a on-chain trading history based on monthly volumes traded on Uniswap or some specific event in the past. So the opportunities are really endless here. Next, on-chain data is just a very niche use case that is very important, but still it's a niche, and it's just the beginning. So what we really want to do is to allow everyone to bring their own data. And it's not necessarily on-chain data, but it may be, for example, price feeds or like your favorite data set that you want to be served by the SQD network and enjoy the permissionless access to data. Further, we want to extend the current filtering language to a full SQL, basically turning SQD network in a true distributed database with all the nice Web3 properties, namely fast and decentralized access to the data. And finally, with solving the data access problem, we want to move one step further into the stack and introduce what we call decentralized indexing endgame, so that you have serverless indexing and you just have the data provider, which is the SQD network, and a small lightweight indexer directly embedded into the web page or in a mobile application. This is a very exciting step, as I say it, simply because that means that one can eliminate the server client architecture altogether and get fully decentralized and device first, offline first application development. This is something that we're definitely looking forward to. This is a roadmap, and all our focus is currently on the SQD portal, to be expected in Q4 2024, and with in Q1 2025 we expect to open up more general data sets. In particular, it would be really awesome to introduce shadow logs, so that you can actually query not just the actual on-chain data, but, for example, shadow logs for popular contracts directly from the SQD network. So this is something we have with a certain level of certainty, and in the future, as I mentioned, we'll work on bringing the full SQL engine to the SQD network. If you find the portals interesting, I really encourage you to apply for credits by scanning this QR code and filling in the form. And the first beta testers will get some free credits in the cloud, not just to testing the portal, but also testing the cloud hosted service itself. And that is going to be my final note for it. And then let's go to the questions.
Yeah, great. Thank you very much. And I think we just leave up the QR code in case people want to scan it and apply for credits. So maybe one of the questions I think that's quite common, and of course it's one of the things we market SQD with, is that it's magnitudes faster than other solutions that are also, like, let's say, in the indexing data access realm. Maybe you can quickly say which part of, let's say, the network architecture enables that.
Yeah, that's a really good question. So one of the first innovation is the actual Parquet file that I mentioned. And it is specifically designed for efficiently extracting only the data that you need across a very large swath of data. So the Parquet file itself is a game changer when it comes to extracting large amounts of data very quickly without sacrificing a lot of CPU or like RAM power. The second enabler is simply the fact that you have so many nodes in the network. So like once you want to get through all the blocks in one of the blockchains, instead of like trying to kick the same endpoint multiple times, you can parallelize your requests across the nodes in the network, and the portal does this naturally and automatically under the hood, because it can send basically like a array of requests to multiple nodes, and the bandwidth multiplies, and then you can consume this data as fast as possible, and only your internet connection is a limiting factor here.
Okay, yeah, I think that makes a lot of sense. I think also one of the things people might sometimes confuse because of the way a lot of blockchain projects are run is that running a worker node on SQD is not like running a validator, right?
Yeah, absolutely. So as I said, SQD Network is not really blockchain, so there is no consensus there. And also running a node doesn't really give you any privileged access to the data, because as I said, each network node has only like a small subset of the data that the SQD network served, and it would have been completely unfeasible even, right, to like put the whole petabyte of data to each node, basically killing the whole concept. So yeah, each node is basically like a pod which keeps a small piece of the data in a cache. So basically more like a shard in a database. Yeah.
Okay, that makes sense. Also, just for people, if you have a question, feel free to put it below. Another thing I think we used to say quite a bit was also that SQD is modular, unlike like solutions that were developed before. Maybe you can go into that a little bit. I mean, modularity as a buzzword has kind of, I think, lost its its hype, but as a network architecture, I think it's still very much useful.
Yeah, absolutely. So we touched upon only the network part, and the whole modularity thesis is that if you want to build a flexible and performant indexer, you need to have a separate layer for accessing the data and a separate layer for decoding and aggregating your data. So up until now, projects like, say, like the graph or any kind of hosted APIs try to put everything into a single box. So you can just get, for example, decoded events for a smart contract, and then you just take this data directly, or you want to get balances for a specific account. Yeah, here we go. But it turned out that this is normally not enough if you want to build some interesting application. So you actually want to listen to the data directly from the blockchain. And in the blockchain, it's really like a dark forest. So it's just like raw bytes. So you need to build a pipeline that takes this data from blockchain, like decodes it, then maybe like puts it somewhere, and so on. And at that point, you realize that actually, even the first step, extracting the data, is actually very hard, and it is the bottleneck in the whole thing, because everything else is more or less standard for a Web2 developer. So what we do is just saying, okay, let us focus on this most important part and solve it in a fully permissionless, decentralized way, and make it as fast as possible. So everything else can be built without sacrificing decentralization, without incurring any significant costs, and basically maxing out the performance so that you can consume this data as fast as it can get. So this is the whole idea behind the SQD network. And on top, we built different open source tooling so that you can work with the data from the SQD network to build a fully end-to-end indexing pipeline. So, for example, you want to have decoded Uniswap data. Here we go. You write a small piece of software that pulls only the data related to Uniswap from the SQD network, decodes it, aggregates it, and puts it somewhere. You want to put this data somewhere in Kafka, or like somewhere in, for example, S3 or like in BigQuery. Yeah, here we go. You have full control of everything once the data leaves the SQD network. So this is the whole concept of modularity. So instead of like trying to offer something that is already cooked, we basically like provide you with a set of Legos, and you can play them together. But at the same time, we guarantee that these Legos are as performant and as reliable as it can get.
Yeah, that makes a lot of sense. And I think so far it's been adopted fairly well. Maybe since you mentioned portals, what do you think is going to be the big shift in how people use SQD once we launch that?
I think the biggest shift would be that I expect a lot more usage from the portals itself, because right now I think most of the time people just build an indexer. So it's kind of a combination of the raw data and data extraction and decoding. This will be, of course, fully supported right now, and will be even 10 times faster compared to what is now. But what I expect is that people would sometimes prefer to feed the data directly from the portal. For example, if they don't want to use TypeScript SDK, or they have some specific requirements, so they don't need to decode this data straight away, or maybe they have some like ad hoc solutions. So yeah, I expect that there will be a lot of unexpected use cases, and it will be way beyond the Squid SDK that we currently offer, like as an open source go-to tool handling the data from the network.
Yeah, anything you personally would like to build with using that data?
Oh, I have a lot of ideas. Actually, the most interesting is the one that I built for the Paradigm Frontiers hackathon. It's like a prototype for the client-side aggregation and the query engine. So the idea is that even with a very rudimentary and simple query language that we currently support against the SQD network, if you pair it with a powerful technology on the client, something like DuckDB, and like a clever way to parallelizing the queries, you can actually build a very powerful setup to query something like Dune Analytics, but built at home. So we don't really have to like pay or like register for an API key, but instead you can actually like aggregate and like pull the data that you need, decode it in place, and so on. So I think that would be like a super interesting project to grow.
Yeah, definitely. Especially, I guess, if you start bringing off-chain data into the mix, it will
Yeah, that would be really cool.
it will unlock a lot more than what we have at the moment. Where you're somewhat limited to building like on-chain stuff. But yeah, so the only, let's say, the only kind of questions we've got so outside of that is, of course, people are always worried about price in crypto, and I don't think we want to talk directly about it. But do you have any like thoughts on how crypto markets are acting, or like how that impacts? Let's say, does that impact us at all, or do we?
Yeah,
Do we
yeah, I was expecting that the most interesting part would be like when
I mean,
Moon
not for me
and
personally, but it like I think like recently there was a panel and I think it was like the Animoca CEO and he said like price is kind of the first discovery in crypto. Like that's how people find new stuff, right? They go to CoinGecko and sort by what has been up the most in the like past 7 days. So it is unfortunate,
yeah,
but
yeah, absolutely. So, and at the same time, I cannot really give any financial advice or like comment on whether I think the SQD price go up and down. But I personally think that it is very cool that you can get SQD not just on a centralized exchange, but on PancakeSwap as well. And we're gonna extend it to different decentralized exchanges too. And having different pairs, more liquidity is something that yeah, we definitely want to work on. And yeah, the rest, I guess, is really about the general crypto sentiment, and it seems to be warming up. And of course, what we are focusing on is the product, and the rest, I think, is just whether we can make it attractive or not. And I do believe that we offer a very unique thing in the space.
yeah, and I mean we have actual users, right? That's always
Yeah,
beneficial as well. If you think about it that way, there's projects that rely heavily on SQD. And I think most people don't even know because if you use something like Interface or Fantasy Top, you will never go and check like how do they get their data unless you're super interested in such questions. So
yeah, absolutely. We're a classical picks and shovels project, and when we see like a gold rush, we basically benefit the most, right? And we are behind one of the most profitable applications. So in particular, like PancakeSwap, as I mentioned, is already using us, right? And there are a lot of very big partnerships in the pipeline. Basically, they are already using us. It's just that they're not announced yet. So yeah, I definitely think that we are like a very much a beta play for a bull market. So if everything goes up, then we just can benefit from it.
yeah, and I think we have the right engineer to non-engineer ratio because I'm one of the few people who are not an engineer at our project, which is usually good for infrastructure. So I think we're winning in that regard.
Yeah, but we also have like a very good quality to quality ratio, I believe. So it's not about the quantity; it's about the
Yeah,
quality
of
always.
course. Of course. Yeah, okay. I think we covered everything. So maybe we can close it off with like, what are you most excited about for the next few weeks? I mean, of course, Portal release is coming soon. But yeah.
Yeah, so basically, Portal is what keeps me up at night, and I would be like really happy to announce it soon. And also, I think we can soft promise another live stream about the SQD economics if we have enough feedback for this live stream, and if the reviews are positive, then I guess it could be a nice tradition.
So yeah, everybody give positive reviews. I mean, we don't really have
Thumbs up.
a review platform, but
Well,
that's something somebody could build, I guess, using SQD. If you do on-chain reputation for your live streams. So
I would be happy to see a lot of likes and reposts
yes,
on X, Farcaster, and YouTube, right? So that would be an
yes.
appreciation. So yeah, don't
True.
forget to do that.
Yeah, and if you have any questions, even though the live stream might be over, but we are still chronically online, so just drop them in the comment and we will pick them up from there. Also, if you do wonder what kind of projects are using SQD already, and well, apart from PancakeSwap, there's many more, and you can find them all on our blog, on our website, among case studies, and there will be more coming. So that's something to look forward to. And yeah, thanks, Dima, so much for this explanation. I think it was great. And yeah, the first time that we did it, I think this in depth for everybody publicly to see. So looking forward to the portal's release. Thanks everybody for watching and see you again soon.